Okay, good afternoon, everyone. So, students, today we are going to start with the next topic, that is relation. Before introducing this topic, we are going to discuss definition, that is Cartesian product of two sets. This definition is very important. Cartesian product of two sets. We have already discussed this definition in the topic of sets, but because this definition is also going to be used in the topic of relation, so firstly, let us have a look at this definition. What is the definition of Cartesian product? If we have given two sets A and B, then A cross B, it is basically the Cartesian product of two sets, which is the collection of ordered pair in which the first element belongs to first set and element at second position, it belongs to the set B. So A cross B is basically the collection of all the ordered pairs in which first element always belongs to set A and second element comes from set B. So this is the most important definition, that is Cartesian product of two sets. Now, by using this definition, we are going to define the next term, that is relation. So what is relation? If A and B, they are two sets. Suppose the set A has elements 1, 2, 3 and the set B consists of two elements, that is 4, 5. Then how can we define the relation? Suppose R is equals to 1, 4, 2, 4, 2, 5 and 3, 4. I have defined a relation R as this. Relation from a set A to another set B is always a subset of A cross B. So what is the basic definition of relation? If A and B are two sets, then relation is always a subset of their Cartesian product, or you can say R is a subset of A cross B. Now I have taken two sets A and B. A consists of 3 elements and B consists of only 2 elements, that is 4, 5. I have defined this relation. Now this relation always comes from A cross B. And what is A cross B? This is the Cartesian product of two sets. For example, if I talk about the Cartesian product of these two sets, then what will be the ordered pair? The ordered pairs are 1, 4, 1, 5, 2, 4, 2, 5, 3, 4 and 3, 5. This is the Cartesian product of the set A and set B. These are the all possible ordered pairs in Cartesian product of these two sets. And what is the relation? It is basically the subset of A cross B. It means the element of relation always comes from their Cartesian product. For example, in this relation, I have taken the pair 1, 4, 1, 5, 2, 4, 2, 5 and 3, 4. It means the element of this relation, they will always come from A cross B. So this is the basic definition of relation. Any doubt in this definition?
No, ma'am.
Okay. So you have to remember only the most important point, that is the relation of any set is always a subset of their Cartesian product. Also, we can understand this definition with the help of an arrow diagram. So the basic definition of relation is the relation is always a subset of Cartesian product of two given sets. Now, if I consider one more example, that is A is equals to A comma B comma C. These are the three elements present in the first set, and B is equals to 1 comma 5 comma 7. These are the elements of set B. Now, before introducing the relation, what are the elements of the Cartesian product? That is A cross B. This is equals to A comma 1, A comma 5, A comma 7. What do you mean by Cartesian product? The first element belongs to the set A and second element belongs to the set B. So it is the collection of ordered pairs. Now what are the maximum possible ordered pair in A cross B? The next is B comma 1, B comma 5, B comma 7, C comma 1, C comma 5 and C comma 7. So this is the value of A cross B, that is Cartesian product of these two sets. That is, I have associated each element of first set with each and every element of second set. But what is the condition? First element belongs to set A and second element always belongs to set B. Now we are going to define different relations. For example, R1 is equals to A comma 1, A comma 5 and B comma 7. Again, I have introduced one more relation, that is R2, which is equals to A comma 5, C comma 5 and C comma 7. We can define different relation from A cross B, but what is the condition? Relation must always be a subset of A cross B. It means it is possible that we can have many relations for given two sets. For example, the third relation is A comma 1, A comma 5, B comma 1, C comma 1 and C comma 7. Like this, you can introduce many relations, but only one condition we have to remember. And what is the condition? The relation must always be a subset of the Cartesian product of two given sets. Now suppose this is the first relation, that is R1. Now I want to understand this relation with the help of arrow diagram. Or you can say, what is the arrow diagram for relation R1? How can we depict the relation R2 with the help of arrow diagram? So let us understand this concept. What is the set A? Set A consists of three elements, that is A, B and C. What is the set B? It consists of three elements, that is 1, 5 and 7. Now firstly, I am going to draw this arrow diagram for relation R1. Now what is the R1 relation? A is related with 1. It means A is in relation with the element 1. A is related with 5. It means A is also in relation with 5. B is related with 7. So B is in relation with 7. It means if there exists a relation between two elements, so we are going to draw an arrow from first element to the second one. This arrow will mention the direction that we are moving from A, and the last point is 1. So this is the arrow diagram for first relation, that is R1. Similarly, if we want to draw the arrow diagram for third relation, that is R3, then what will be the arrow diagram? Sets will be same. What are the sets? Sets are A and B having elements A, B, C, and the element of second set are 1, 5, 7. Now, what is the third relation? A is related with 1. So we have drawn an arrow from A to 1. A is related with 5. It means A is also associated with 5. B is related with 1. So I have drawn an arrow from B to 1. C is in relation with 1. So draw an arrow from C to 1. C is related with 7 also. So draw an arrow from C to 7. So these are the arrow diagrams that I have drawn for relation R1 and R3. So diagrammatical representation of relation is clear to everyone?
Yes, ma'am. Yes, ma'am.
Okay, beta. So this definition is basically based on the term that is Cartesian product. So what is the simplest definition of relation? If we have given two sets A and B, then the relation is always a subset of A cross B. It means relation is again a collection of ordered pairs, but that ordered pair always comes from A cross B. So simple point to remember is relation is always a subset of A cross B. So this point is very important. If definition of Cartesian product is not clear, then beta it's very difficult to understand the definition of relation also. So the next important point is, after this, now suppose I have taken a set A and it consists of total m elements. Again, the second set is B. It consists of n elements. I have taken two sets A and B. First set has m number of elements and second set has n number of elements. Then what is the total number of ordered pairs? This is very important. How many ordered pairs are possible in Cartesian product of two sets? A is the first set. This consists of m element. B is the second set having n element. Then what is the total number of ordered pair? Ordered pair always come in the Cartesian product. It means the total number of ordered pair, this is equals to m into n. So if we have an example, if we have given a set A which consists of 3 elements and second set B, this consists of 2 elements, then what is the total number of ordered pairs? So the answer will be 3 into 2, which is equals to 6. So total number of ordered pair can always be calculated by this formula, that is m into n. What is m? These are the number of elements present in the first set. And what is n? This is the number of elements present in the second set. Now, this is very important point, that how to calculate the total number of ordered pair. Now, the next important point is total number of relations from A to B. How many relations exist for two sets, that is A and B? So total number of relations, this can be calculated by using this formula, that is 2 raised to power m into n. So beta, these 2 points are very important. The first point is how to calculate the total number of ordered pair, and formula is m into n, where m is the number of element of first set and n is the number of element of second set. And second point is total number of relation for two sets, that is from set A to B. So what is the total number of relation that exists from set A to set B? And this is the formula, that is 2 raised to power m into n. So these 2 points are very important. Any doubt in these 2 points?
No, ma'am.
Suppose I have taken an example. The set A consists of 4 elements and B is a set which consists of only 2 elements. Then what are the total number of ordered pair?
8.
Very good. The total number of ordered pair, this is equals to m into n. M is equals to 4, n is equals to 2. It means the number of ordered pair, this will be equals to 8. And what is the total number of relations?
2k power 8.
Very good. 2 raised to power 8. It means total number of relations from set A to B, this is equals to 2 raised to power 8. So it means if two sets are given, then it is possible to have more than one relation. Even 2, 3, 5, 6, 10, 15, many relations can exist for the same two given sets. So these 2 points are clear to everyone. Any doubt in this? Hanji Betaji, is it clear?
Yes, ma'am.
Yes, ma'am.
So after these 2 points, The next definition that we are going to discuss is domain and range in case of relation. For example, we have given a relation and the question is find out the range and domain of given relation. This question can come in 2 marks, that is in section A. Relation is given and you have to find out what is the domain and range of that given relation. So what is the formula, what is the definition, and how can we calculate the domain and range of any given relation? So firstly, let us understand this with the help of an example. Suppose we have given a set A which consists of 3 elements, that is A, B, C, and B is a set which consists of 2 elements, that is 2, 5. Now there will be some relation. Suppose I have taken this relation R is equals to A, 2, B, 5, C, 2, and C, 5. This relation is already given and you have to find the domain as well as range. What is the domain? The element present at the first position, they are known as the element of domain. In relation, that is, in these ordered pair, the element which are present at the first position, they are known as domain, and the element which are placed at second position, it is known as domain. So what will be the domain? Domain is equals to A, B, C, because in this relation, the elements at first position are A, B, and C. So only 3 elements are placed here. So A, B, C, this will be the domain of given relation. And what about the range? Range is basically the element which are placed at second position. So what are the elements at second position in this ordered pair? This is equals to 2, 5. So this is the definition of domain and range. So you can say, what is domain? Domain of any relation is basically the set of first coordinate of the ordered pair. So domain is basically the set of all the first coordinate of these ordered pair. And what is the range? This is the set of all the second coordinates of the ordered pair. In this ordered pair, the elements which are placed at first position, they form the set of domain, and the element which are placed at second position, they always form the set of range. So any doubt in the definition of domain and range?
No, ma'am.
Okay, beta. So beta, we have already done this definition with the help of an example. The relation is always a collection of ordered pairs. In these ordered pairs, the elements which are placed at first position, they form the set of domain, and the element which held at the second position, they form the set of range. So this is the definition of domain and range. So this is very important definition. Now the next one is, next definition is related to domain and range. The next definition that we're going to discuss is inverse relation. This is the basic introduction of the topic relation. And now we are going to start with the next definition. This is again the basic definition based on domain and range. So what is the next term? That is inverse relation. What is the meaning of inverse relation? Suppose we have given 2 sets A and B, and R is a relation from set A to B. If R is a relation from set A to set B, then what is the inverse of this relation? Firstly, the inverse of any relation, it is denoted by R inverse. And this is a relation from set B to A. It means when we want to find the inverse of any relation, the position of these 2 sets is interchanged. If R is a relation from A to B, R inverse means inverse of this relation. So what is the inverse of this relation? This is also a relation, but it is a relation from set B to set A. For example, suppose I have taken this definition, the general notation. If R is a relation which consists of all the ordered pair in which first element belongs to set A and second element belongs to set B. This is the definition of simple relation. Relation is basically a collection of ordered pairs in which first element belongs to set A and second element belongs to set B. Now what is R inverse? This is equals to B comma A. Why B comma A? Because R inverse is a relation from set B to set A. So in this case, the elements of set B will cover the first coordinate and the element of set A, they will cover the second coordinate. So in this case, B belongs to set B and A belongs to set A. The element will come from the same set, but their position will be interchanged. Now first coordinate will become second one and second coordinate become first one. So this is the definition of inverse relation. Now, what is the relation between domain and range of R and R inverse? Hanji beta, I have a very interesting question for all of you. Relation and inverse relation. These two definitions are already explained. Now I have a question. What is the relation between domain and range of R and R inverse? Anybody, can you define this relation? Any idea?
Ma'am, domain of relation is equal to range of inverse relation.
Very good. It means the domain of relation R, it will become the range of inverse relation. For example, please have a look at this definition. This is the relation and this is the definition of inverse relation. Now, what is the domain? Domain means the elements which are placed at first position. So, domain of R, this is equals to, now in this case, the position of A and B is interchanged when we are talking about the inverse relation. So now this is domain, this is range, but in this case it will become opposite. Domain will become the range and in this case the range will become the domain of inverse relation. So we can say domain of relation, this will become range of inverse relation, and similarly the range of relation R, it will become domain of inverse relation. Any doubt in this result? I will explain this result with the help of symbolic form of these two relations. If you have any doubt, then you can ask. Otherwise, we are going to start with the next definition. So this result is very important, that domain and range of simple relation and inverse relation, they will interchange. Or you can say this is the result. Hanji beta, any doubt in it?
No, ma'am.
Okay. So this is all regarding domain, range, inverse relation. Now we are going to start with the next topic, that is the different definitions of relation. And now this topic is very important. Beta, if the definitions are clear to you, it means you are able to simplify the examples. But if you have some doubt in the definition, then please clear the doubt at the same time. Otherwise, you are not able to simplify the theorem and example of this topic. So firstly, before introducing the different definition, we shall firstly cover the definition, then example of that definition will also be discussed. Then I will also explain the same definition in symbolic form. So in case you have some doubt, then you can ask at the same time. Because this topic is very important, we are going to use this definition in the next theorems. So the first definition that I'm going to start is reflexive relation. This is the first definition. The first definition is a reflexive relation. Now, what is reflexive relation? Suppose we have given a set A. Firstly, note down the definition. A relation R on a set A is said to be reflexive if we have given a set A and R is any relation defined on this set, then R will be reflexive if every element of A, is related to itself. Any relation R which is defined on a set A is said to be reflexive relation if, what is the condition? Every element of this given set is related to itself. For example, let us understand this definition with the help of an example also. Suppose we have given this set. A is equals to 1, 2, 3, 4. Now we are going to define a relation R for this set. And what is the relation? Suppose I have defined this relation 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, and 4, 4. This is the relation that I have defined. Now this relation is reflexive or not? What is the criteria to check? If every element of this set is associated with itself, or you can say if every element of this set is related to itself, then this relation will be reflexive. For example, what is the first element? First element is 1. 1 is associated with 1. Yes. Second element 2. 2 is associated with 2. Yes, it is true. Third element is 3. Again 3 is associated with 3. Next element is 4. 4 is also associated with 4. It means every element of set A is in relation with itself. So we can say the relation R is a reflexive relation. So this is the definition of reflexive relation. So a relation R on a set is said to be reflexive if x, x belongs to R for every x belongs to A. For each element of this set, there must exist this relation. Any doubt in this definition? And the students' definition of reflexive relation is clear? Anji Beta ji, if you have any doubt, then you can ask. Otherwise, we are going to quote some more examples.
मैम एग्जांपल फिर से समझा दो.
Okay, beta. Beta, this is the set A. I have taken a set A which consists of 4 elements, that is 1, 2, 3, and 4. And I have defined this relation. This is the relation that I have defined. Now I want to check whether this relation is reflexive or not. What is the condition? You will take all the elements of this set one by one. And if there exists a relation between the same element, that is, every element of set A is related to itself. If every element of set A is in relation with itself, then you can say this is the reflexive relation. For example, first element is 1. 1 is related with 1. Yes. Second element is 2. 2 is related with 2. Yes. Third element is 3. 3 is also in relation with 3. Last element is 4. 4 is also related with 4. It means for each element of set A, we have a relation which is related to itself, which consists of those pairs that are related to itself. So this relation is said to be a reflexive relation. Any doubt? And the students, this definition is now clear?
Clear, ma'am.
I'm going to take one more example because I didn't get proper responses from all of you. Reflexive relation, this definition is very important because if this definition is clear, then you are able to discuss the definition of equivalence relation, partial order relation, and so on. Suppose I have taken A is equals to 1, 2, 3. This is a set which consists of 3 elements. Now I am going to make different relation for this set. different relation I'm going to introduce, then we shall check whether these relations are reflexive or not. For example, if I have introduced first relation as 1, 1, 1, 2, 2, 2, and 2, 3. This is the first relation. Second relation is 1, 1, 1, 2, 2, 2, 3, 3. This is the second relation. And also I have introduced one more relation, that is 1, 1, 1, 2, 1, 3, and 2, 2. These are the three relations. Now I am going to check one by one whether these relations are reflexive or not. What is the condition? A relation will be reflexive if every element of set A is related with itself. हर एक element self के साथ related होना चाहिए, same image होनी चाहिए. First element is 1. 1 is related with 1. Yes. Second element is 2. 2 is related with 2. Yes. Last element is 3. But 3 is not related with 3. 3 की 3 के साथ image नहीं दी हुई. It means this relation is not reflexive. 3, 3, it is not present in R1. It means R1 is not a reflexive relation. First topic is clear. The first note.
Yes, ma'am.
Okay. Now let us move to the second relation. First element is 1, 1, 1 is present. बेटा इनके अलावा और भी बहुत से पढ़े होंगे, जैसे यहाँ पे 1, 2 है, 2, 3 है, हमको चेक करने की जरूरत ही नहीं है. Why? Because मैंने वही चेक करने हैं डाटा रिलेटेड टू इटसेल्फ होंगे, जिनकी सेम इमेज हो. ठीक है. फर्स्ट एलिमेंट इज 1, 1 is related with 1. Yes. Second element is 2, 2 is related with 2. Yes. Last element is 3, 3 is in relation with 3. 3 की 3 के साथ भी इमेज है. तो क्या R2 रिफ्लेक्सिव रिलेशन है?
Yes, ma'am.
Yes, ma'am.
आप क्या लिखोगे? Since x comma x belongs to R for every x belongs to A. If we consider any element from set A, this condition is always satisfied. It means relation R2 is a reflexive relation. Now next is R3. Now let us have a look at this relation. R3 is reflexive or not?
No, ma'am.
No,
Why
ma'am.
R3 is not reflexive?
3, 3 is not present.
Three is not there.
Because for first element 1, 1 is available. For second element 2, 2 is available. But for third element 3, 3, 3, this doesn't belongs to relation R3. It means R3 is again not a reflexive relation. So any doubt in this?
No, ma'am.
So beta, from last 2 or 3 examples, what we have concluded? We have concluded a relation will be reflexive. This is the most important point to remember. A relation is reflexive if x comma x belongs to R for every x belongs to A. It means for all the elements of set A, this condition must be satisfied. Only then the given relation will be a reflexive relation. So this is the definition of reflexive relation. Or you can say a relation is not reflexive when the relation is not reflexive. A relation is not reflexive if x comma x doesn't belongs to R for any x belongs to set A. If there exists even a single element in set A for which this condition is not satisfied, then you will say the given relation is not reflexive. So beta, I have write down these 2 important points. The relation will be reflexive when this condition is satisfied for each and every element. But if there exists even a single element in set A for which this condition is not satisfied, then you will say the relation R is not a reflexive relation. So this is all regarding reflexive relation. Now, the next point is identity relation. Identity relation is actually, this definition is very similar to the reflexive relation. So that's why we are going to discuss this definition now. identity relation. We're going to discuss this definition along with reflexive relation because these two definitions are much similar, or you can say student mostly confused in these two definitions. Next is identity relation. If we have given a set A, let A be any set, and R is a relation which consists of all the ordered pairs which are related to themselves, then this relation is said to be an identity relation. Can you tell what is the difference between identity relation and reflexive relation? Any idea? Distinction between identity relation and reflexive relation.
मैम जो जैसे ऑर्डर पेयर में 1 2 3 रहेगा तो सिर्फ 1 1 2 2 3 3 आइडेंटिटी में रहेगा लेकिन 1 2 नहीं रहेगा.
Very good. It means in case of identity element, every element is related to itself only. हर एक एलिमेंट केवल सेल्फ के साथ ही रिलेटेड होगा. फॉर एग्जांपल, इफ आई कंसीडर दिस एग्जांपल, A is a set which consists of two elements, that is 1, 2. I have defined this relation R 1 1 1 2, 2, and again I have defined one more relation that consists of only two pairs, that is 1 1 and 2 2. Which relation is identity and which is reflexive? Can you define?
लास्ट वाला आइडेंटिटी होगा मैम,
Very
ऊपर वाला
good.
रिफ्लेक्सिव है.
Very good, beta. It means identity relation is that relation in which each element is related to itself only. Only word is used here. I have again and again focused on this word. A relation is said to be identity relation if every element of set A is related to itself only. That is, first element is 1, 1 is related with 1. Second element is 2, so 2 is related with 2. इसके अलावा there doesn't exist any ordered pair. So this is identity relation. Now let us have a look at first relation. For 1, 1, 1 is present. For 2, 2, 2 is present. But beyond these two pairs, we have one more pair, that is 1, 2. It means this relation is a reflexive relation, because in reflexive relation there exists different ordered pair. In case of reflexive relation, we have ordered pair which are related to itself and other ordered pair also exist. But in case of identity relation, we have only those pairs in which element is related to itself only. So what is the most important point to remember? In case of identity relation, every element is related to itself only. Every element is related to itself only. So this is the most important point to remember. Hanji students, after these two examples, do you have any queries regarding identity and reflexive?
No, ma'am.
So
No, ma'am.
distinction between both the definition is clear to everyone. Very good, beta. So identity relation is basically a relation in which every element is related to itself only. Okay. The next definition is symmetric relation. This is the next definition. So the next definition is symmetric relation. Now, what is the symmetric relation? First of all, we are going to have a look at the definition. If we have given a set A, suppose we have given a set A, then define a relation R on a set A. Then if we have defined a relation R on a set A, is said to be symmetric if x comma y belongs to R, this implies y comma x also belongs to R for x comma y belongs to A. So this is the condition for symmetric relation. X and Y, these are the elements that comes from the set A. Now when the relation R, which is defined on set A, is symmetric, what is the condition? Suppose we have defined a relation R, we have taken a pair x comma y from the relation R, and if the inverse of this ordered pair, what is the inverse of x comma y? That is y comma x. If the inverse of every ordered pair of relation R is also present in relation R, then you will say this relation is a symmetric relation. This is the condition. Xy belongs to R. This implies y comma x also belongs to R. So R is a relation that I am going to define on any set. If I have taken any ordered pair from the relation, for all the ordered pair, if their inverse is also present in the same relation, then you will say the given relation is a symmetric relation. So let us understand this definition with the help of an example. Suppose A is a set which consists of 4 elements, that is 1, 2, 3, 4. And I have defined a relation R which consists of ordered pair, that is 1, 3, 1, 4, 3, 1, 2, 2, and 4, 4. I have defined this relation. Suppose I have taken here 4, 1. This is the relation that I have defined on a set A, that is 1, 3, 1, 4, 3, 1, 2, 2, and 4, 1. These are the ordered pair of the relation. Now I want to check whether this relation is symmetric or not. What is the condition? First pair is 1, 3. 1, 3, this is present in R. What is the inverse of 1, 3? That is 3, 1. So 3, 1 is also available in this relation. It means the condition of symmetric is satisfied for the first pair. 1, 3, this is the first pair that I have taken from this relation, and inverse of 1, 3 is 3, 1. This is again present in the relation. So condition of symmetry, it is satisfied for the first pair. Now let us move to the second pair. What is the second pair? 1, 4. And what is the inverse of 1, 4? That is 4, 1. 4, 1 is also present in R. Now let us move to the next pair. 3, 1, inverse is 1, 3, again present. Next is 2, 2. And what is the inverse of 2, 2? It will be again 2, 2. So 2, 2 is already available in the relation. So this relation is said to be a symmetric relation. Why? Because inverse of every ordered pair is also present in the same relation. So this is the definition of symmetric relation with example. Any doubt in this definition?
No, ma'am.
Okay. So symmetric relation is basically a relation in which inverse of every ordered pair of the relation R is also present in the same relation. Now let us consider one more example. I have taken set A which consists of 4 relations, and let us now define a relation R2 whose elements are 1, 1, 2, 2, 3, 3, and 1, 3. Is this relation symmetric or not?
No, ma'am.
नहीं है मैम.
Okay.
No, ma'am.
Why R2 is not symmetric?
1, 3
3,
are common.
1 is not present.
Very good. 1, 3, this is taken from the relation R2. Inverse of 1, 3 is 3, 1, but this is not available in the given relation. So inverse of this ordered pair is not present in the given relation. It means the relation R2 is not a symmetric relation. So this definition is clear to everyone. What do you mean by a symmetric relation?
Yes, ma'am.
Okay. So after this definition, now we are going to move to the another definition, that is transitive relation. Next is transitive relation. Relation is always defined on a set. It means firstly we are going to consider a set A, then we shall define a relation R on that set, then we shall check the condition. What is the condition for reflexive? What is the condition for symmetric, and what is the condition for transitive? If a particular condition is satisfied, it means the given relation will be transitive, symmetric, or reflexive accordingly. So now let us have a look at the definition of transitive relation. Now, what is a transitive relation? If A is any set, suppose A is a set, then a relation R on a set A, then relation R on a set A is said to be transitive, is said to be transitive if and only if. What is the condition? X comma y belongs to R and y comma z belongs to R. This implies X comma Z also belongs to R, where X comma Y comma Z, these all elements are taken from set A. So this is the condition for transitive relation. Set A will be given. We have to define any relation R on set A. Then when this relation will be transitive, what is the condition? We have to consider two ordered pair from given relation, X comma Y and Y comma Z. These two ordered pairs will be taken from the relation, and what we have to check? We have to check if whether X comma Z it is present in R or not. This is the condition to check whether a relation is transitive or not. So this is the condition to check whether the relation is transitive or not. Now we are going to understand this definition with the help of an example. This definition is most important. Result is already written here. So I am going to consider this example. Suppose A is a set which consists of 4 elements, that is 1, 2, 3, 4, and I have defined a relation R which consists of these ordered pairs. That is 2, 1, 3, 1, 3, 2. Just the ordered pairs are 3, 2, 3, 1, 2, 1, 4, 1, 4, 2, and last pair is 4, 3. I have defined these ordered pair in the given relation. Here we have 2, 1. So beta, firstly have a look at this example. I have taken a set A, and this set consists of 4 elements, that is 1, 2, 3, and 4. And after this, I have defined a relation R on set A. And what are the ordered pair of this relation? 3, 2, 3, 1, 2, 1, 4, 1, 2, and 3. So this is a relation that I have defined. Now I want to check if whether this relation is transitive or not. So this is the condition. What is the first pair? 3, 2. This is an ordered pair that I have taken from the relation. Now 2 से शुरू होता और भी ordered pair है X, Y, and second ordered pair is Y, Z. So first I have taken 3, 2, and this ordered pair starts from 2. It means I am going to select 2, 1. So 3, 2, and 2, 1, these are the two ordered pair that I have taken from the relation R. And what I want to check? I want to check if whether 3, 1, this is present in relation or not. 3, 1 is also present in relation. So firstly, for the first pair, I have checked the transitive relation is verified for the first pair. And similarly, we shall check it for the rest of the pair. ये चीज clear है सबको?
Yes, ma'am.
Yes, ma'am.
Okay, so next pair is 3, 1, but there doesn't exist any ordered pair which start from 1. It means we shall not check the condition for transitive for this ordered pair. Because why? Because there doesn't exist even a single pair which starts from 1. So leave this pair. Next is 2, 1. Again, there doesn't exist any pair which start from 1. Leave it. Similarly, for 4, 1, leave this pair. Next is 4, 2, leave this pair. Last is 4, 3. 4, 3, this is taken from the relation, and 3, 2, this is also taken from relation. If I consider the pair 4, 3, then we have two conditions to check. 4, 3, 3 से शुरू होते दो ordered pair है. One is 3, 1 and second is 3, 2. Now we are going to check whether these two pairs satisfy the condition of transitive relation or not. 4, 3 लिया, 3 से शुरू होता pair है 3, 2. So leave the common element. We are left with 4, 2. 4, 2 is already available in the relation. Consider these two pairs 4, 3 and 3, 1. Leave the common element. So we are left with 4, 1. 4, 1. This is again present in the relation. It means this given relation is a transitive relation. Any doubt in it? Hanji students, the definition of transitive relation is clear or not? 4, 2 belongs to R, and there exists an ordered pair which start from 1, that is 2, 1. Leave the common element. Then again we are left with 4, 1. 4, 1 is already available in the relation. So given relation will be a transitive relation. Why? Because for every x, y belongs to R and y, z belongs to R, x, z is also present in the given relation. So this relation will also be a transitive relation. So beta, this is all regarding the definition of transitive relation. So beta, after these three definitions, the next is very important, that is equivalence relation. After this definition, we are going to simplify some example based on these definitions, that is reflexive, symmetric and transitive. But this definition is because linked with the last definition. So firstly, let us go through this definition, that is equivalence relation. What is equivalence relation? Let A is any set, then a relation R on set A is called equivalence relation. What is the condition for equivalence relation? Number 1, it must be reflexive. The relation must be a reflexive relation. What is the second condition? It must be a symmetric relation. And what is the last condition? Relation will also be a transitive relation. So if these three properties are satisfied, then you can say the given relation is equivalence relation. So these three properties are to clear the definition of equivalence relation. If we have given a set A, we have defined any relation R on this set, then when this relation will be equivalence relation, if it satisfies these three properties. And what are the properties? Number 1, it must be reflexive. What is the definition of reflexive? Every element is related to itself. Second, it must be symmetric. What is the definition of symmetric? If x, y belongs to R, it means y, x also present in R. That is, inverse of every ordered pair is also available in the same relation. And what is the condition for transitive? If x, y and y, z, they are taken from relation R, then x, z must also be available in the same relation. So if these three properties are satisfied, then you can say every given relation will be a reflexive relation. So beta, this is all regarding the definition of equivalence relation. Then suppose we have this question in your marks to define equivalence relation. It means you have to define each and every property. Don't just write down a relation will be equivalence if it is reflexive, symmetric and transitive. Then you will get only 0.5, that is half mark. So it means if you get this definition in your exam, you have to define each and every property. Reflexive, that is x comma x belongs to R, for every x belongs to A. For symmetric, this is the condition. For transitive, this is the condition. And also we can quote an example along with this. For example, I have taken this example. A is a set which consists of three elements, that is A, B and C. And I have defined this relation A comma A, B comma B, C comma C, A comma B and B comma A. Now please tell me whether this relation R is equivalence relation or not. Take 1 minute. Check whether this relation is equivalent relation or not.
Yes, ma'am, equivalent. Yes.
Okay. What about the rest of the students? The relation is equivalence relation or not? This you have to verify. Relation will
Yes,
be
ma'am.
equivalent if these three properties are satisfied. Okay, you all are saying that this is an equivalence relation. Very good, beta. Elements are ABC. First condition is reflexive. A is related with A, B is related with B, C is related with C. So relation is a reflexive relation. For transitive, A comma B is taken. What is the inverse of A comma B? That is B comma A. It is also available. So relation is symmetric. Now to check the transitivity, A comma B is here, B comma A is present in R. So A comma B is in R, B comma A is also present in R. It means A comma A, it must be present in the relation R. So A comma A is already here. Again, A comma B is taken from R and B comma B is also taken from R. It means A comma B, it must be available in the R. It is also available in the given relation. So since this relation R, it satisfies all the three properties, that is reflexive, symmetric and transitive. Hence we can say the given relation is an equivalent relation. First example. But now we are going to simplify some example, practical question. These questions are based on the definition that we have recently discussed. The first example, it will cover section 8. Suppose we have given a relation R. Suppose R is a relation defined on set A, which consists of these elements. This is the first example that we are going to discuss. A is a set which consists of these elements 2, 3, 4, 5, 6, and R, this is the relation that we have defined on set A. Now, what type of elements are present in relation? Relation is already defined. Let R is a relation defined by X is relatively prime to Y. X is relatively prime to Y. Then write the elements of relation R. Then write down the elements of relation R. So beta, this is the first example that we are going to discuss. A is a set. R is a relation defined on set A. How R is defined? R is basically a collection of those elements in which X is relatively prime to Y. What do you mean by relatively prime? Any idea? What are relatively prime numbers? Relatively primes means GCD of X and Y is equals to 1. Here he has given the condition that X is relatively prime to Y. It means the greatest common divisor of x and y is equals to 1. Okay, this is equals to 2, 3, 4, 5, 6. These are the elements of set A, and we have defined a relation R on this set. How we have defined the relation? 2, 3. 2, 3. This is the ordered pair. GCD of 2 and 3. This is equals to 1. 2 और 3 के बीच में कुछ भी common नहीं होता. Next ordered pair is 2, 5. You can't take 2, 4 because if we have taken a pair 2, 4, then their GCD is not equals to 1. Why? Because 2 is a number which is common to 2 as well as common to 4. What is the next pair? First is 2, 3. Next is 2, 5. What will be the next pair?
थ्री कोमा
3,5.
Very good. 3, 4 भी आएगा. 3, 5. GCD of 3 and 4 is also 1 because these two numbers come from different tables. Next.
5,6.
4, 5. 5, 6. So these are the ordered pair. That is 2, 3, 2, 5, 3, 4, 3, 5, 4, 5, and 5, 6. So this is the relation R, which consists of basically those ordered pair which are relatively prime, or you can say those pair whose GCD is equals to 1. GCD means the greatest common divisor. It means now you have some question in which conditions will be given, and you have to define the relation accordingly to what condition is given in the example. So any doubt in this question?
No,
No,
ma'am.
ma'am.
So one more example that we are going to discuss. The next is, let R is a relation defined on set X. Set X consists of elements that is 0, 1, 2, 3 up to so on infinity. Defined by R is a relation defined by this equation: x square plus y square, this is equals to 25. Write the relation R as ordered pairs. So beta, this is the next example that we are going to simplify. We have given a set X which consists of all the elements starting from 0, that is 0, 1, 2, 3, 4, 5 up to so on infinity. R is a relation that is defined by using this condition. What is the condition? X square plus y square, this is equals to 25, and you have to write down what is the value of this relation and how can you define this relation R. X square plus y square, this is equals to 25. X and y, these are the elements that comes from the given set, that is from X. So how can we find out the value of R? Beta, please have a look at board. This is the given condition: x square plus y square, this is equals to 25, or you can say y square, this is equals to 25 minus x square. So if x is known, you can calculate the value of y also. First of all, what is the value of x? This is equals to 0 because the element of set X, they are started from 0. So if x is equals to 0, then what is the value of y? Y, this is equals to 5. Y square is equals to 25. It means the value of y, this is equals to plus minus y. Either y is 5 or you can say y is equals to minus 5. But x and y, these two elements are taken from set X, and X is a collection of positive number. It means we shall reject the negative value. That's why I have taken y is equals to 5. Is it clear why we have not taken the negative sign?
Yes, ma'am.
Because x and y, these elements are taken from set X, and X is basically a collection of only positive number. So that's why we are going to reject this negative number. So if x is equals to 0, the value of y, this is equals to 5. Now, what is the next possible value of x? This is equals to 1. So what is the value of y square? This is equals to 24. y square, this is equals to 24. It means this doesn't belong to set z because this is not a positive integer. This will comes in under root like 3 point something, 4 point something. This is not an integer. Y square, this is equals to 24. It means the value of y, this will come in decimal because this is not a perfect square. So this value of y doesn't belong to the set of integers because we have taken the set of positive integer. It means this ordered pair doesn't belong to relation. So reject this value. Next is x is equals to 2. So what is y square? 25 minus 4. This is equals to 21. Again, this doesn't belong to the set of integer. Y square is equals to 21 means y is equals to under root of 21. Under root, again, this doesn't belong to the set of positive integer. So leave this value. Similarly, if x is equals to 3, then what is y square? 25 minus 9, which is equals to 16. So what is the value of y? Y is equals to 4. And 4, it belongs to the set of positive integers. Next, if x is equals to 4, then what is y square? 25 minus 16, which is equals to 9. It means the value of y, this is equals to 3. Again, 3 belongs to the set of integers. So this pair will also be considered. Any doubt up to this point? And the students, any queries up to this?
No, ma'am.
Okay, the next is if x is equals to 5, then y square, this is equals to 25 minus 25, this is equals to 0. So the value of y, this is 0. If I have taken x is equals to 6, then what is y square? 25 minus 36, this is a negative number which doesn't belong to set x. So after this value, all the values of y will be negative. It means इसके बाद हमने कुछ नहीं करना, your process is terminated. If you take x is equals to 7, 7, 7 the 49, 25 minus 49, this is again a negative number. So negative number doesn't belong to this value, this set. It means we have to stop our process at this step. So what is the relation R? So relation R will consist of ordered pair. First is 0, 5. 1, this, it is not selected. Again 2, 21, it will be rejected. Next is 3, 4. Next is 4, 3. And next is 5, 0. This is the value of relation R. Any doubt in this example? हाँ जी students, example clear है सबको?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, students, now we have discussed different definition and examples of relation, and now I'm going to generate polls. So first poll is, but I have launched the first poll.